Hello viewers, in today's lesson we want to solve for x in this beautiful expression. What is x? So the first thing we need to do is to put this base in the lowest base that appears in this expression, which is base 5. So to do that, we have 25 and 125. So this 25 can be simplified as 5 raised to power 2, while the 125 can also be simplified as 5 raised to power 3. So having put in this, then our expression now becomes 5x plus 2 multiplied by 5 raised to power 2 into bracket raised to power x minus 1 equals to 5 raised to power 3 into bracket raised to power 2x minus 1 plus 10. Okay, from here, what we need to do next is to consider the simplification of the power using the power rule. With this identity, a power m into bracket power n can be written as a power m n. Using this identity, we use it to simplify the exponents. Okay, that then gives us 5 raised to power x plus 2. So multiplying this together, we now have multiplied by 5 raised to power 2x minus 2, which will be equals to 5 raised to power 3 multiplied by 2x. We have 6x minus 3 plus 10. So from here, the next thing to do is to combine the expression at the left hand side. So to do that, we also consider another identity of this nature, base a power m multiplied by base a power n, to be given as base a power n plus n. We consider this identity as well to combine the exponents of the left hand side. So that gives us 5 raised to power x plus 2 plus 2x minus 2 will be equals to 5 raised to power 6x minus 3 plus 10. Okay, this is what we are left with. So from here, what we need to do next is to simplify the expression at the left hand side. So from the exponent, we have plus 2 subtract minus 2. So we are now left with 5 raised to power x plus 2x equals to 5 raised to power 6x minus 3 plus 10. So that then gives us 5x plus 2x give us 3x equals to 5 raised to power x minus 3 plus 10. What we need to do here is to subtract this expression from both sides in order to isolate this 10, this constant. So we now have 5 raised to power 3x minus 5 raised to power 6x minus 3 equals to 5 raised to power 6x minus 3 minus 5 raised to power 6x minus 3 plus 10. Okay, so this right hand side then becomes 5 raised to power 3x minus 5 raised to power 6x minus 3 equals to 10. So from here, what we can also do is to express this by factorizing 5 raised to power 3x. So we have 5 raised to power 3x into bracket 1 minus 5 raised to power 3x minus 3. Close the bracket, equals to 10. This is what we are given now. So this can also be written as 5 raised to power 3x into bracket 1 minus 5 raised to power 3x over 5 raised to power 3. Close the bracket, everything equals to 10. Okay? So this expression or this equation is transcendental and cannot be solved algebraically. So what we need to do is to use the logarithm to approximate the solution. So from here, what we now do is to let 5 raised to power 3x to be equals to y. So wherever we see this expression, we replace it with y. So this expression now becomes y into bracket 1 minus y over 5 raised to power 3 into bracket, close the bracket, equals to 10. So 5 raised to power 3 can then be written as, we have y into bracket minus 1 minus y over 125, close the bracket, equals to 10. So from here, we can multiply 125 throughout this expression. So we have multiply by 125 then we close the bracket, equals to 10 multiplied by 125. Okay, so we can now open this bracket. We have 125y minus y squared equals to 1250. Okay, 125y multiplied by this bracket, then we'll be given 125y minus y squared equals to 1250. 10 times 125 equals 1250. So from here, what we now have is to manipulate. So from here, we now have, from here we have 125y minus y squared equals to 1250. So we now have to rearrange this expression. First, we move this 1250 to the left hand side to equate everything to a 0. So we now have 125y minus y squared minus 1250 equals to 0. So rearranging this, we have minus y squared plus 125y minus 1250. Everything equals to 0. Multiplying through by minus, we then have y squared minus 125y plus 1250 equals to 0. So this led us to a quadratic equation, which we are going to use the quadratic formula to solve. So from the quadratic formula, we have y to be equals to minus b plus or minus square root b raised to power 2 minus 4ac all over 2a. So from here, our a equals to 1. From this, the coefficient of this. Then our b equals to minus 125. From this term, minus 125. So our c, the value for c, is then 1250. 1250. So we now input all this value into the equation. So the equation then becomes y equals to 125 minus 125. The minus cancel the minus already in the equation. So we have 125 plus or minus square root 125 raised to power 2 minus 4 multiplied by 1 multiplied by 1250 all over 2 multiplied by 1, which is equals to 2. So from here, we then have our next step to be equals to 125 plus or minus 125 squared will then give us square root 15,625 minus 4 multiplied by 1 multiplied by 1250, we have 5,000. So all over 2. From here, the next thing is to subtract the expression in the square root. So we have 125 plus or minus, if we subtract this from this, then we get the next step to be square root of 10,625 all over 2. Okay, from here we can use our calculator to get the square root of this, and using the calculator we have the value to be 125 plus or minus 103.08. Everything will be equals to 2. So from here, we can now express the value of y in two ways, in two. So the first one will be y, which is going to be y1, will be equals to 125 plus 103.08 over 2. And that can be approximately given as, using our calculator, we have 114.04. will be the y1. Okay, then the y2 will now be given as 125 minus 103.08 over 2, and that can also approximately be given as 10.96 if we resolve this expression. 125 minus 103.08 divided by 2. So we arrive at approximate answer of 10.93, and that will be our y2. Okay, from the y2 we can now from there, what we then need to do is to solve for x. I haven't gotten to value for y. So since y equals to 5 raised to power 3x, so we take the logarithm of both sides of base 5 in order to solve for x. We then have our next step to be 3x will be equal to log of base 5 y. This is what we have now. Then in order to isolate x, we divide both sides by 3. Divide by 3, divide by 3. 3 goes with 3. We have what? X equals to log of base 5 y divided by 3. So from here, we can then put the value of y to get x. So x will now be given as the value of x when our y equals to 114.04. So we have log of base 5 114.04 over 3. Okay, if we resolve this with our calculator, we then arrive at the value of x, which will be given as, so the numerator can be expressed as 2.94 over 3 as the value of x. Mind you, this will be x1. Okay, we are working for x1 presently. So if we divide this together, we then have x1 to be approximate answer of 0.98. Okay, x1 equals to an approximate number of 0.98. So having gotten the x1, we can also solve for x2. So that will then give us when our y, that is the y2, equals to 10.96. So we come back to our expression. We have x to be equals to log of base 5 y divided by 3. So this can then be written as log of base 5 10.96 everything over 3. If we also resolve this with our calculator, from the numerator we have our answer of the numerator to be given as, with our calculator, 1.49 divided by 3. Okay, and this will be given as s2. Okay, and our x2 will be approximately given as 0.50, 0.50, which means overall, in general, our value of x is 2. Our value of x is 2. why our value of y is also given as 2 value. So when our x equals 2, our x1 equals 2 is 0.98. Okay, that is when our value of y1 is equals to 114.04. So likewise, when the value of x is equals to 0.50, then our value of y is given as 10.96. These are our positive value of y and x. So here is another playlist to help you out on how to deal with algebraic expression. Click on it and continue to watch.